Hey everybody! Today I'm going to cover chapter 8. Specifically, we're going to talk about arrays. And arrays are something that is very useful when you're coding, when you need to sort a group of items. And it's just a very useful data structure. So let's begin. These are the learning objectives that we are going to cover today. So we're going to cover just array basics, then how to search for an element inside of an array sequentially, then how to process the contents of the array, then what are parallel arrays, what are two-dimensional arrays, and any arrays that are 3 or more dimensions. So as I said before, an array will allow you to store a group of items of the same data type together. So why would we do that? Because instead of creating multiple similar variables, such as example here, employee 1, employee 2, employee 3, and so on, we can just create a place where all of the employees would be stored in memory, just one place, instead of creating a single space in memory for each one of those employees. So instead of doing that and taking too much space, we can just create one variable, such as an array, and then we can tell that this array will store this many variables inside of it, this many elements. And for example, here we have 50, right? The number in the brackets will show you how many elements that array is storing or can store. So as we can see here, we declared a string of employees, an array, string array of an employees, and the size of that array is 50. And the same thing here, we declared a real array, and remember that real is just also sometimes called a float, and it is a decimal number. So here we created an array of decimal numbers that will tell us how many sales amounts are. And there's seven elements, so 7 numbers of sales amounts that we're storing in this array, hypothetically. And yeah, the number in the brackets is the size of the array. Couple more of important terms for you to know. So the storage locations are called elements. So every single thing that you store is called an element of the array. And whenever we need to know where that element is located, we call that number a subscript. So a subscript will let you know where that element is located. And in most languages, the subscript will start at 0. Not 1, but 0. So, as you can see here, we're going to begin with element 0 instead of starting with an element 1. That's a very important thing to know and to remember, because when you go on later with using the arrays, you can catch a lot of syntax errors if you forget that your element starts at 0, not at 1. So, just pay attention to that. By using our subscript, we can assign the values to each subscript individually. And what it means is just instead of typing out all of the values at the same time that you want to assign to your array, you can do this. So set, we have an array of numbers, probably integers, based on the values that we are assigning to it. So we have an array of integers called numbers, and to the subscript at 0, we want to assign it to 20. So the first element of our array is going to be 20. And remember I told you we start at 0, that's why we call it the first element. The first element will start at 0. Then the second element at the subscript of 1, we're gonna assign it to 30 and so on. The third element 40, the fourth element 50, the fifth element 60. Yes. Here's an example of the hours array. So we have an array called hours, also that consists of integers. And as you can see here, this is how I imagine it in my head personally, just like each block, and each block is connected to the other block that's in front of it and that's behind. So as you can see here, element at position 0, our first element is 40. Then our second element at the position 1 is 20. And then our third element is 15. So if we wanted to add more, this is all we would do. Just add another element. For example, it doesn't matter which number, 7. And this would be hours at 3. So it just keeps going. Then if you wanted to add more, it would be 4, 5, 6, 7, and so on. So there's two ways to initialize your array. And then remember, initialize is just to assign a value. So you can either initialize it to 0, or you can provide specific values for your array. So as you can see here, we have an example of a string array that is called days that can store up to 7 elements. And this is the important part, up to 7 elements, but remember that our subscript starts at 0, so the last subscript, the last position of the last element is going to be 6. It's not going to be 7, even though there's a 7 here, it's still going to be 6 because remember we start at 0. And here, we just declare a couple of variables, the days of the week, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And what this example shows us that if we will try to access a subscript of our array that is at 7, if we try to access position 7, it's going to be invalid because we don't have a subscript of 7. Our latest subscript is 6. So this is the most common error that happens when people forget that you start your array at 0. So as I said before, just remember that you start at 0. So even if you have declared your array as 7 elements, your latest subscript is going to be 6. It's not going to be 7. So you won't be able to access an element at the position of 7. The last element that you can access in this array is going to be at 6. There is also such thing as a partially filled array. So that happens only when some of your elements, for example, you declare, let's look at this example that we just had. For example, if we declare the same array that can hold up to 7 elements, and if we would declare only the first 3 days, Sunday, Monday, and Tuesday, right? If we didn't have all of this, then your array would be partially filled. And instead of having all of these values, your array would just have empty values. So it would be just, basically, your elements would be nothing. So when your array is partially filled, depends on the data type that you're using. But if it is a string, then the empty values will just continue being empty values. If it's an integer, then 0 will be stored as variables. And if it's a float, the same thing, as 0 would be stored as integers. But also depends on your programming language. This is just overall general idea. Okay. Then imagine this situation. You have an array with 10,000 elements and only 2,000 elements are filled in that array. So 8,000 elements are empty. We would not want our program to process the empty elements, right? Because that would just be a waste of time. We would get absolutely nothing from it. So that's why when you're working with arrays that have big number of elements, you must have an integer variable that will count how many items are actually in the array that are usable. So when our array is empty, we would have 0 stored in that variable. And every time you would add something to your array, add an element, you would have to increment that variable by 1, or by the amount of values that you add to your array. So if you add 6 values to your array, then you would increment that variable that's keeping track for us up by 6. So some languages will provide a for each loop for you. And you are familiar with loops already. And with the for each loop, it's working only with arrays and or some other sorts of data types that work as an array. And it will iterate or do something for the amount of elements that are in the array. So for example, if you have 8 elements in the array and you use your for each loop, that loop will run 8 times for each element in the array. So it's in the name, just for each, and try to remember that for each element in something. That's what this loop means. As you can see here in this example, so we declare an integer, a constant integer of size equals 5. Then we declare our array Also, remember size 5. So our array can hold up to 5 integers. And then we assign 5, 10, 15, 20, 25 to the elements that are in our array. So these are our elements that we're going to work with. And then we're going to declare an integer called num, because that's going to help us with our loop. And as you can see here, for each number in numbers, display num. So what all it's going to do, it's just going to go into your array, and num is going to start at 0. So it would, because remember, if we don't assign a number, it's just going to assume that it holds 0. And what this loop is going to do is going to start at 0, subscript 0 in your array, and it's just going to display what element is at that location. So with this example, it's going to display 5, and then the number is going to be incremented by 1. So instead of number being 0, it's going to equal 1. So it's going to print 5, 10, 15, 20, 25, and so on, until there is no more elements in the array. That's all it's going to do. Okay, so a sequential search algorithm is the simplest way to find an element in your array. So it's not really efficient. It's not efficient at all for big arrays, but if you have just like 10 elements or 15 elements, that's the perfect way for you to find whatever you're looking for in your array. And all it's gonna do, it's just gonna go through your whole array or until it finds your whatever you're looking for. So for example, if we have an array of integers like 1, 2, 3, 4, and 5. Let's have it here, our array. So what this loop is going to do for us, what this algorithm is going to do for us, it's just gonna look for whatever number you want it to look for, and it's gonna compare every single element until it finds it. So for example, if we're looking for 4, right, we say let's find the location of element 4. What this algorithm is going to do is gonna enter at the very beginning, and it's gonna look at number subscript number 0, and it's gonna ask you, is 1 equal to what we're looking for? No, because we're looking for 4. Okay, it's just gonna move on to the next one. Is 2 what we're looking for? No. Let's move on to the next one. Is 3 what we're looking for? No. Is 4 what we're looking for? Yes. This is a hit. So it's going to tell you whatever, depends on what you're trying to achieve with your algorithm, but it will either tell you, yes, this element exists in your array, or it's going to return you the number of the subscript where it's located. Depends how you want this algorithm to work for you. So either it will tell you, yes, it exists, or it will send some information back to you, such as the location of the element. You can use loops to process your content of the array, and you can calculate average. For example, if you have a bunch of numbers in your array, all you need to do to calculate the average is to add all of the values together and then just divide it by the size of your array. Pretty simple. Now, you can also find the highest and lowest values in your array. And to find the highest value, you just create a variable that's going to hold your highest value. And then you will compare that variable to each and single element of your array. So you were going to start at element 0, and we are going to assume that this is the highest number. Because remember, our variable does not hold anything yet. We're still looking for our highest value. So let's assume that our element 0 is the highest, and then all you will have to do is create a loop that's going to compare that value to each element in the array. And if a comparison is made and the new value that you're looking at is higher than the value that is stored in our variable, then you just assign that value, the new one, to our variable. All it is. So let me show you an example. For example, if at element 0, let's say this is our variable called var, and if it's holding, for example, 2, right? And then in our array, let's say our array is 2, 16, 15, 7. Doesn't really matter. So our loop will go in, look at 2, assume that this is the highest number, Then we're going to move on to the next one, and we're going to look at 16, and we're just going to compare. Is 16 bigger than 2? Yes, 16 is bigger than 2. Then what our algorithm is going to do, just assign that value to our variable. Pretty simple. And then, so now our greatest value is 16. Again, we're assuming that this is the biggest value because we haven't looked at the rest of our array yet. And all this algorithm is going to do is look at the next value, 15, and it's going to compare, is 15 greater than 16? No. Move on to the next one. Is 7 greater than 16? No. And this is the end of the array. So here we found our largest value in our array. The same process goes with the lowest, finding the lowest value, but instead of comparing the two and asking, is this element bigger than the one that we're storing, we're asking, is this element smaller? So absolutely the same process. Another good practice of coding is called parallel arrays, if you will ever need to use it. But what it does is you create two basically identical arrays, but identical in a sense that they have the same number of elements, and each subscript, as you can see here, 0, 1, 2, 3, 4, is the same as here, 0, 1, 2, 3, 4. And there is some correlation between the two arrays. As you can see here, person 1, person 2, person 3, person 4, and person 5, they have their assigned values. So person 1 will be assigned to subscript 0. So any subscript 0 in any of the arrays that we have will be and will store information about person 1. The same with person 2. Person 2 will be subscript 1, person 3 will be subscript 2, and so on and so on. So this way you can easily find information, all of the information that you have stored about something or someone. As you can see here, if we were to create a loop that would print the name and the address of each person, we would just have to look at the subscript. So we would just have to print subscript 0, print information that's at subscript 0, and it would print all of the information for person 1. Then print information at subscript 1, it would print us the name and the address of person 2, and so on and so on. Now, a two-dimensional array, that's where it gets a little bit complicated for people and a little bit harder to understand this concept, but I can teach you a trick. If you start thinking of two-dimensional arrays as just arrays stacked on top of each other, that's what helped me personally. Or you can also think of them as rows and columns. So let me show you how we would access our values. You need two size variables when you're creating your array, two-dimensional array, one for the amount of rows and one for the amount of columns. And it's important for you to remember that the first number that you will see is going to be for rows and the second one is going to be for columns. So for example, you might see something like values 3, 4, right? Don't be scared. Don't be alarmed when you see this. It's just, it will tell you that this is a two-dimensional array. And all you will have to do if you want to find your value that's at the location 3 and 4, let's look here. We will look at the rows first. What's number 3? Remember that we started 0, so 0, 1, 2, 3. So this is where our value will be located. And then we look at 4. 0, 1, 2, 3, 4 in this row. So this would be our value that we would be looking for. So nothing too crazy. You just have to remember that the rows come first and the columns come second. Now you can also have 3 or more dimensions of your arrays, and this is all it would look like. So again, rows, our columns, and then we just add pages. This last number is going to be for pages. So page 0, page 1, page 2. And so on, as many pages as you would like to have. Now, when it comes to Python, you don't really create arrays, you create lists instead of arrays, but again, they function absolutely the same way. It's just the way it's called. In Python, they're called lists instead of arrays. So, as you can see here, the declaration is the same as when we would declare any of our variables. It's just the name that you want to call that specific array. We don't need any data types. We don't need any like declare or set. You just say the name that you would like this array to have. Then you put your equal sign. Then you open your brackets. And then you put whatever elements you want your array to have. And then you close your brackets. So yeah, this statement will declare your whatever name. Right here it's even numbers. It's going to declare it as a list, and then the items inside the brackets are going to be the elements of that list. Another example here, we have an array called names, and it stores Molly, Stephen, Will, Alicia, and Adriana. If you want to access your elements, you will do that with a subscript. Again, the same idea as we discussed earlier. Subscripts start at 0. Important. 0. Now, for example, right here we declared an array called numbers, and it has 3 elements, 0, 0, 0. So it's just basically an empty array that we're working with. Now we want to assign some elements into our array. We want to input some values. So here we have numbers, and we're telling at subscript 0, at position 0, we want to have an element 10. Now, at subscript 1, we want to have an element of 20. And at subscript 2, we want to have 30. This is what it is going to do. So this is going to be your new array. 10, 20, 30. Instead of being at 0, 0, 0, because we assigned a value to each subscript that is in that array. Another useful function called len, that stands for length, will just return how many numbers you have in that list, how many elements you have in that list. So for example, here, size will be 3, because how many elements do we have in this array? 1, 2, 3. So this size, after we use our function len on our array numbers, is going to return 3, and size will equal 3. Your length function will be very useful in a loop, so you don't go out of bounds of the array whenever you're working with it. That's another mistake that a lot of people do when they start working with arrays or lists, is that they go out of bounds. Your computer will indicate that there's no more elements in the array, and you're trying to process something that is not inside of your array. So your program will crash every time you will try to get out of bounds of your array. Now, Python also has its version of the for each loop, but in my opinion, in Python it is easier than in any other language that has a for each loop. All you have to do, as we can see here, we have our array called numbers, and it has 4 elements, 99, 100, 101, and 102. All you have to do if you want to work with the numbers in your array is you need to say for. This does not have to be n. This can be any word that you want it to be. For something in numbers, remember the name of our array, numbers, then you put your colon and whatever you want to do. So in this example, we do print n. So all it will do, it's just going to print your numbers, 99, 100, 101, and then 102. This is what this loop is going to do. You can't create 2-dimensional lists in Python or 2-dimensional arrays, and all you will have to do is just basically create an array inside of an array. And I know it might be a little bit confusing, but you just have to memorize this, and this is how you would declare it. So you would put your brackets, then you would put whatever array you want to be in there. Put a comma, and then the next array, and then close the brackets. So as I said, array inside of an array. And how this will look like, it's going to look like this. 1, 2, 3, 10, 20, 30. Remember that little thing that we had. Let me find. right here, this figure right here. So this is what it would look like with our Python example. This is what it would look like. Again, 1, 2, 3, 10, 20, 30. As you can see here, our first array, our second array. And if we would want to reference any of the elements or find which element is stored is in certain locations, remember the first number is rows, the second number is columns. So 0, 0 would be this element, 1. 0, 1 would be, let's look, row 0, column 1. This element, then 0, 2 would be this element, and so on. This would be 1, 0, this would be 1, 1, this would be 1, 2. So this was all I had for today. Hope you enjoyed, and let me know if you guys have any questions, or reach me by email. Thank you.